for continuation. Dimension of a constant is 1, dimension of mass, dimension of length, and dimension of an acceleration. So Lt minus 2 to the power z, that means m to the power x, L to the power y, as well as z. We have a z here, t to the power minus 2z, left hand side, 0, t minus 1, t1. So x is equal to 0. By comparing the powers on both sides of the equation, we get y plus z is equal to 0 and minus 2z is equal to 1. From this we get z is equal to minus half. Replacing minus z here, we get y is equal to half, and we already know x is equal to 0. So replacing these three powers in this equation, we get k into m to the power 0, L to the power half, g to the power minus half. Now m to the power 0 means it turns out to be 1. So there is no dependency on mass on the time period of a simple pendulum. You can write this in this form. Now k cannot be determined using dimension analysis. This is one of the handicaps of dimension analysis. It has to be derived from experimental values, which turns out to be 2 pi. We come to know t is equal to 2 pi root over L by g. And lastly, we take 2 or 3 examples of or rather questions of dimensions. The first question: if force F, length L, and time t are considered basic units, find dimension of mass. Out of these three, length and time are fundamental units, whereas force is not a fundamental unit, but here we have to consider it as basic or fundamental units. So from Newton's second law, we know that mass is force upon acceleration. Now here force is taken as a fundamental unit F. Now acceleration we know as Lt minus 2. So the answer will be F L minus 1 T plus 2. We'll try out another example. We know that current is a fundamental unit. Current is a fundamental unit, whereas voltage is a derived unit, whereas voltage is a derived unit. But if in the question it states that take V as base unit and derive the dimension of I. Now P is equal to V into I, we all know. So I is equal to P by V. We have to calculate the value of or the dimension of I. So it's P by V, power by voltage. Now the dimension of power, or rather work by time, comes out to be mL square t minus 3, and voltage is taken as the base unit. So the dimension of current comes out to be ml square t to the power minus 3 v minus 1.